Okay, guys, last question. And again, it's position, velocity, acceleration. Except now we're given a table of both position values and velocity values. So we want to approximate Ben's acceleration. If acceleration is the derivative of velocity, well, then we're going to want to take the slopes of velocity values. So 5 is somewhere between 0 and 10. So 5 is somewhere between 0 and 10. And if I want to estimate his acceleration at 5, well, that's going to be the difference in the velocity values, 2.3 and 2, so v of 10 minus v of 0 over 10 minus 0. And they really try to make it a little bit tricky by throwing in these extra values. So I have 2.3 minus 2 over 10 minus 0, which is 0.3 over 10. Move the decimal point 1 meters per second squared. And again, if I want to take the if I want to take the acceleration, well, it's the derivative of velocity. And how do I get the units? Meters per second per second. So the velocity is measured in meters per second, and the time is measured in seconds. If the question had said, estimate Ben's velocity at 5, then would we be using these position values. But since it's an acceleration, we want the derivative of velocity. Whenever we see velocity in absolute value, we're talking about the total distance. So is the total distance Ben travels in meters from t is equal to 0 to t is equal to 60 seconds. In the third question, we had that without the absolute values, and that's the displacement or the change of position. But whenever I have velocity and absolute value, the direction doesn't matter. So we have total distance traveled. Now let's estimate what that is. This is still part of B. Sorry. We want to use 3 subintervals. So we want to go from 0 to 10. We want to go from 10 to 20, 10 to 40, which is 30 units apart. And we want to go from 40 to 60, which is 20 units apart. And we want to use a left Riemann sum. And it's a little bit tricky because, again, there's so many values here. But I have 10 times, well, if I'm using a left Riemann sum, these are velocity values. So the velocity value on the left of 0 and 10 is 2. So 10 times 2 plus 30 times the velocity value that's on the left, 2.3, plus 20 times the velocity value that's on the left, 2.5. It might be a little small. No, I'll be able to do that. All right, and finally on C. Okay, so must there be a time between 40 and 60? So if I look at this table between 40 and 60, must there be a time when the velocity is equal to 2? Well, the velocity is 2.5 at 40 and 4.6 at 60. So there's nothing here that tells me my velocity has to be equal to 2. But if I look at my position values, it goes from 9 to 49, so a change of 40 units. in 20 seconds. So by the mean value theorem, because the slope between these 2 points is 2, because 40 divided by 20 is equal to 2, then at some place that velocity has to be equal to 2. So by the mean value theorem, there is a t for 40 is less than t is less than 60, such that v of t is equal to 2. And then I have really 2 ways of justifying this, because I could either say Ben's position at 60 minus his position at 40 over 60 minus 40 is equal to 2, or I could say what they are, so 49 minus 9 over 60 minus 40, which is equal to, 40 over 20, and that's equal to 2. I'm going to do part D over here. Okay, so between 0 and 10, must Ben's position, between 0 and 10, must Ben's position be 120 meters. So I start off at 100, and I go to 136. So somewhere between 0 and 10, I can't go from 100 to 136 without going through every value that's there. And the theorem that says that we have to go through every output value is the intermediate value theorem. So by the intermediate value theorem, there is a t for 0 is less than or equal to t, which is less than or equal to 10, such that his position has to be equal to 120, because 120, and then there are 2 ways to say this too, 120 lives between his position value at 0 and his position value at 10. Or I could say exactly what they are. I could say, 100 is less than 120, which is less than 136. So I can't go from his position value at 0, which is 100, to his position value at 10, which is 136, without going through that 120. And that's the intermediate value theorem. And how do we know which one it is? Because if I'm talking about like the value of a function, that's intermediate. If I'm talking about the slope of a function, that's the mean value theorem. Okay, guys, that's those. Let me know if you have any questions, and I'll see you all soon.